Welcome back, student. Now today we'll discuss on today we'll take an example on numerical on the previous topic. That is basically the distance between or perpendicular distance between a plane and origin of the cube. And the expression was that d is equal to a square, d is equal to a divided by under root of h square plus k square plus l square, where h, k and l are the Miller indices of a particular plane. Okay, or you can say that this is also the interplanar distance, d also as expressed as your interplanar distance. Okay, now in your problem it is given that in a diagram the 1 1 1 is a particular plane of a cubic lattice. So for a particular cubic lattice, the plane is given to you and you have to calculate the interplanar distance between in between the origin of the cube and the plane. That plane is given is your 1 1 1. So as you proved in the previous lecture that for a particular distance, okay, for the particular distance or particular perpendicular distance between a plane and the origin of the cube, that is basically the plane was given to you that HKL. Now the value is given in your numerical that here plane is basically 1 1 1. Okay, now as you know, this is a cubic structure. Okay, this is a cubic structure, and that cubic structure indicates A B C D E F G H, where H is the origin of the cube, and if you draw a perpendicular line which can intercept of the plane which is given to you, that is 1 1 1. So what is the distance between the plane, that is basically the drawn by the particular given plane, and the origin of the cube? Now as you know that the value of the particular plane is given as h is equal to 1, k is equal to 1, and as well as l is equal to 1. Now the reciprocal of that, it gives you that particular the point or intercept point. So the reciprocal of h, k and l, that gives you the intercept point. That is nothing but 1 by 1 or a 1 by 1 and 1 by 1. That gives you that 1 1 1. Now this is the intercept point. Okay, now the interplanar distance will be that d is equal to a divided by under root of h square plus k square plus l square, where a divided by the value of h, k and l is given to you that 1 1 1. So that answer will be a by root 3. So this is the interplanar distance, and you can draw the plane from the intercept point. The intercept point is 1 1 1. So as you know that the cubic structure, basically the atomic distance between two atoms, the distance between two atoms, that is basically a, and we assume that the distance is basically unit distance. So all the distance will be is 1 unit. Okay, so you can draw that this is the point in x-axis is 1, for y-axis the intercept point is 1, and z-axis is 1. So this is your x, you can draw x, y and z. So this is your intercept point. Now you can draw the line, or you can connect the line. Okay, so this is the plane which is given to you, and you have to draw the interplanar distance. If you draw the plane perpendicularly from the origin of the cube, it just cut of a particular plane that is given to you, that basically E, G and D. Okay, so the distance between the plane and the origin of the cube, that is a by root 3 angstrom. Okay, the unit is very important, angstrom. Now the next problem is given to you that a FCC crystal has an atomic radius of 1.246 angstrom. So the atomic radius given to you, and what about the interplanar distance, that indicate that D200, that means the distance or interplanar distance or perpendicular distance in which the plane is given to that 2001, like HKL. So similarly, the interplanar distance when the plane is given to you that 220 or HKL is equal to 220. Similarly for D11 also. Okay, now as you know that is given to you that the atomic radius, that is R, that is given to you that 1.246, and the crystal given to that is FCC crystal. Okay, as you know, there is a FCC crystal structure. So the relationship between the lattice parameter and the atomic radius is that A is equal to 4r by root 2. Okay, A is equal to 4r by root 2. So A is equal to 4r by root 2. So is equal to 4 into r. R of the radius is given to that 1.246 angstrom. So write down these values here, 1.246. So 4 into 1.246 divided by root 2, that is A is equal to 3.52 angstrom. Okay, now you have to calculate the interplanar distance or the perpendicular distance or the distance between the origin of the cube and the plane is drawn between given the particular Miller indices. Now it is firstly given to you that the plane, that is 200, for 200 plane, as you know that d is equal to our interplanar distance, d is equal to a by under root of h square plus k square apply l square, as we proved in the previous lecture video, that d200 is equal to the value of d. Okay, value of a is given, value of a, sorry, r is given, so you can calculate in terms of part to a between the relations. You can apply the relationship between the radius of the atom, atomic radius, and the lattice constant. As you know that the FCC crystal structure A is equal to 4r by root 2, so A is equal to 3.52 angstrom. So write in these values here, and you know that for the plane D200 it indicates the interplanar distance when the plane is given to that 200. That means H value is 2, K's value is 0, and L value is 0. So you can calculate the interplanar distance between the plane that is given to D200 will be 1.76 angstrom. Similarly, you can calculate the for D200 similar fashion, that A is equal to 3.52, and for D200 will be H is 2, K is 2, and L is 0. So you can calculate 1.24 angstrom for the plane D200. And similarly for D11, that will be 3.52 divided by under root of 1 square plus 1 square plus 1 square, that gives you that 2.03 angstrom. So these are the these are the perpendicular distance, or these are the interplanar distance in between the origin of the cube and the defined plane. The defined plane is basically 200, 220, 111. These are the defined plane. So obviously the interplanar distance will be the different. So that is basically 1.76, 1.24, and 2.03 angstrom. Okay. Now let's move another problem. So that is the next problem regarding your interplanar distance. Okay, so this is regarding the interplanar distance, and so that the next problem is that in a simple cubic lattice, so you have to calculate, you have to prove that for a simple cubic lattice, the separation between the successive lattice plane. For a simple cubic lattice, the separation between the successive lattice plane, that plane is given to that 100, 110, and 111. So that is given to as a Miller indices, and what is the ratio of that particular planar interplanar distance or perpendicular distance between these planes. Okay, as you know that the formula or expression was that for a particular interplanar distance, or the distance between the origin of the cube and the particular or a plane, or that is basically for HKL like that. So the expression was that D is equal to DHKL. You can write also DHKL. So that the general expression is equal to A by under root of H square plus K square plus L square. Okay, so these are the general expression. Now for a particular plane 100, that for D100, you can put this value here in terms of H is equal to 1, K is equal to 0, L is equal to 0. You can calculate the value that A will be here. For D110, that will be A by root 2. For D11, the value will be A by root 3. Now you have to calculate or show, you have to prove that for a simple cubic lattice, the separation between the successive lattice plane that are in the ratio of 1 is to 0.75 is to 0.58. So D100 is equal to D100 is equal to D11, that is equal to A is to A by root 2 is to, sorry, A is to A by root 2 is to A by root 3. Now, so in both expressions that a is common, so a will be cancelled. After all, 1 is to 1 by root 2 is to 1 by root 3. So d100 is to d110 is to d11 is equal to 1 by root 2 is equal to 0.71 and 1 by root 3 is equal to 0.58. So the ratio of the interplanar distance, or the distance between origin of the cube and a plane for d100 and d110 and d11 is equal to 1 is to 0.75. so this heaven 1 is to 0.58. okay, so these are that's all for this problem. Okay, thank you very much for listening and watching me, and goodbye.